So for this week we are doing the gummy bear, experiment. I live up in New England and I thought it was kind of funny. We have, instead of gummy bears, we have little lobsters that I found at the gas station instead of gummy bears, and they were cheap. So to break up the normalcy of gummy bears, I have little gelatinous lobsters. Alright, so in here I have my one in the distilled water, and then this one is in the salt water solution. And first of all, I thought it was important to kind of look into the ingredients of my little gummy lobsters. The gummy bear or lobster is a small fruit candy that has a bipolymer gelatin, and then other ingredients, of course, is sugar, citric acid, and then coloring. For these, it's all red dye, but in a normal bag, you could have multiple colors. When you place the gummy bear or lobster down into the distilled water, it starts swelling. Mine is almost to the point where it's going to break apart if I touch it. And this happens because the gelatin forms hydrogel in the water by taking up as much water as possible into itself. And the gelatin has functional groups like carboxylic acid and amine, not sure if I'm saying that quite right, groups which have hydrophilic properties. The swelling of the gummy bear occurs as a result of the inhibition of water by the gelatin, as this is a semi-solid. And the phenomenon that the water is actually taken up inside the structure of the gel micelles. The micelle part is held firmly by the molecules constituting the micelle owing to forces which are probably chemical in nature and causes an increase in volume of the micelles. This process stops when a certain limit is reached, kind of like the limiting reaction we studied in Chemistry 1, depending upon the cohesion between the molecules of gelatin constituting the micelles. Water remains in the intermicellary spaces of the polymer, and hence a little increase in size that I observed over about the last 6 hours. But after this gummy bear or lobster is stored, because the gelatin polymer is soluble in water to some extent in room temperature, and due to water uptake, its inside pressure is increased. So we're now at the point where it's going to just break apart. My little lobster in the salt water has not swollen much. The water has a more pinkish tone to it than the other one, and I don't remember my next point. When added in salt water, the intrinsic viscosity of the gelatin decreases with increasing salt concentration, so the solubility of the gelatin will be enhanced in salty water. This can be explained by the tertiary electroviscous effect. As more salts are added, the intrachain electrostatic repulsion in gelatin is weakened by the stronger screening effect of small ions of salt. So when the gummy bear or lobster is placed in the saltwater solution, it starts to solubilize quickly in the solution instead of swelling. And after a few hours, the whole gummy bear is dissolved and the resulting solution becomes more viscous than the initial one. The solution becomes reddish pink due to the presence of coloring agents. Mine did not dissolve as the research I found, and I think that's due to I didn't quite add enough salt into my little pool for my lobster. But it did not see quite as much fluid intake as did the distilled water one.